California drowns not in a single storm, but in persistence. What followed was not a freak cloudburst or an isolated weather anomaly, but a prolonged stress test of infrastructure, geography, and preparedness, one that the state could not endure unchanged. Atmospheric rivers had been studied, modeled, and named. Levees had been reinforced, mapped, and rated. Yet when duration replaced intensity as the dominant force, the margins quietly disappeared. What remained was exposure. California's winter has always lived on a knife's edge, a fragile equilibrium between drought and disaster, where rain is both salvation and threat. This year, that balance did not bend, it broke. For 11 consecutive days, a massive atmospheric river locked into place over the eastern Pacific and California's coastline. Scientists later classified it among the strongest and longest-lasting atmospheric river events ever recorded in the state, with water vapor transport levels exceeding 1,200 kilograms per meter per second, well into the highest category on the atmospheric river scale. At its peak, the system was carrying more water vapor than the average flow of the Mississippi River, suspended invisibly in the sky. The first rain arrived quietly, then the sky unraveled. What followed was not episodic rainfall, but continuous loading. In parts of northern and central California, gauges recorded 25 to 40 inches, 635 to 1,000 millimeters of rain in less than 2 weeks. In the Sierra Nevada, snow water equivalent climbed at rates unseen in modern records, over 300% of average for the time of year, while warmer air pushed snowlines higher, converting what should have been stored snowpack into immediate runoff. Rivers responded with speed and violence. The Sacramento, San Joaquin, and Salinas rivers surged past flood stage for days at a time. Some levee systems, engineered for short, high-intensity floods, not prolonged saturation, failed not because they were overtopped, but because they were soaked through, losing internal strength grain by grain. Engineers would later confirm what satellite data already showed. Levee integrity declines sharply after 72 to 96 hours of continuous pressure. This storm applied pressure for nearly 3 times that duration. Neighborhoods vanished. From the air, entire communities dissolved into brown inland seas. Water depths reached 10 to 15 feet in some low-lying areas, enough to submerge single-story homes completely. Highways became canals. Rail lines warped and lifted. More than 200,000 Californians were forced to evacuate, many with only minutes of warning, their departures framed by sirens, emergency alerts, and the low, relentless thrum of helicopters overhead. Emergency responders raced rising water that moved faster than vehicles could. In some counties, swift water rescues increased by more than 400% compared to an average winter. Power was cut deliberately to tens of thousands to prevent electrocutions. Drinking water systems failed as treatment plants flooded. The official death toll climbed slowly, grimly, each number representing someone who misjudged depth, speed, or time. Even as rescues continued, the Pacific refused to rest. Satellite imagery showed additional atmospheric rivers already forming, their moisture plumes stretching thousands of miles toward a state still underwater. Recovery plans stalled before they began. On television, meteorologists struggled for language. 1 in 200-year event, 1 in 500-year storm. But the labels rang hollow. Californians could hear the water. They could feel homes shaking as levees slumped. They watched boats move through suburban streets where children once rode bikes. And beneath the chaos, harder questions surfaced. Atmospheric rivers are not new. California has always depended on them for 30 to 50% of its annual precipitation. What has changed is their behavior. Research shows that for every 1 degree Celsius of global warming, the atmosphere can hold about 7% more water vapor, turning familiar storms into prolonged, punishing events. This storm was not unprecedented in existence, but in persistence.
As residents fled to higher ground, one realization settled in alongside the floodwaters.
California had prepared for impact. It had not prepared for endurance. And endurance, it turns out, is what breaks systems first. This chain of disasters was set off by a phenomenon recognized for its intensity: the atmospheric river. These are not rare. California gets between 8 and 11 atmospheric rivers each year, but their impacts are usually minor. What made this event historic was not just the ferocity,
but the stubbornness. It began as a broad ribbon of moisture, extending thousands of miles from near Hawaii straight toward the west coast. Meteorologists watched nervously as forecasts warned that this would be a significant event. But California had experienced major storms before. This time, the system stalled. Rather than passing swiftly, it anchored along the coast, riding a reoriented jet stream and refusing to budge eastward. 11 days later, the grim uniqueness was clear, a conveyor belt pouring water with little pause at previously unmatched volumes. Rains fell in torrents, not gentle showers. In the mountains and foothills, 5 inches fell before midnight on the first night. Along coastal ranges, gauges overflowed. The Russian River, usually tranquil, surged to hazardous flood levels in hours. Emergency crews distributed boats and jet skis to neighborhoods that had been dry at sunrise. They pulled families through second-story windows, children huddled on makeshift rafts, parents clutching pets, neighbors sobbing on cell phones as driveways turned into rivers. Elsewhere, the intensity of the system spared no region. San Francisco logged over 2 inches in a few hours. San Diego's hillsides saw deaths from falling trees, and in Los Angeles, rising waters forced motorists to abandon vehicles as freeways became impassable. Mud and debris torrents, unleashed from fire-scarred hillsides, roared into neighborhoods still marked by last year's burns. The storm simply wouldn't end. Jet stream steering currents repeatedly directed new pulses of moisture to the same battered state. With the ground saturated and swollen rivers offering no respite, each day's rainfall added new danger. In the Central Valley, fields turned into sprawling lakes, their boundaries marked only by treetops and stranded utility poles. Emergency alerts blared, evacuate or risk being trapped. The looming question, how much more could the levees, the land, and the people withstand? But it wasn't rain alone that overwhelmed California. The disaster deepened because infrastructure built to protect, the levees in particular, was not prepared for such relentless force. Most of California's levees, totaling around 24,000 miles, were designed over a century ago and maintained in fits and starts. Many had never faced such sustained pressure or volume. On December 29th, the crisis escalated further. The Green River Levee in Washington was the first major structure to fail in the region during this storm sequence. The breach came suddenly. One moment, it was strained but intact. The next, a wall of water surged through the gap, flooding sleeping neighborhoods. Thousands scrambled to evacuate, leaving homes as alarms sounded through the night. California's own vast network watched anxiously. Already, levees were groaning under the immense strain. In Marin County, floodwaters crept 4 feet deep, swallowing RV parks and floating vehicles away. In the Sacramento-San Joaquin Delta, farmland was overtaken by a glassy inland sea. As the new year approached, many Californians spent their countdowns monitoring news rather than celebrating. The next atmospheric river was forming over the Pacific. Meteorologists noted a clear pattern. The events were not random, but formed in a near-continuous train, each new storm pounding the same fragile defenses.
Levee breaks led to catastrophe.
The water swept in faster than it could be drained, filling whole communities in minutes. Cities built below the heights of their levees became bowls. Every inch of rising water another step toward disaster. The soundness of aging infrastructure, built for a gentler era, was plainly giving way. By early January, the situation verged on chaos. Another powerful pulse of atmospheric river activity brought further disaster, pouring 3 to 5 inches in a single day across the Bay Area. BART stations became creeks. The Mission District in San Francisco was inundated. Flood protocols not used in over a decade activated citywide as water pooled in basements and submerged cars. Inland, Sacramento received 4 inches in under 2 days. The American River swelled, and Folsom Dam reached full capacity, forced to open spillways to relieve pressure. The South Yuba River breached its banks on January 4th, sending a 6-foot wall of water crashing across levees not built for such stress. Some residents had only minutes to flee. Emergency crews executed dramatic rescues, pulling people from rooftops, trees, and stranded cars as waters rose swiftly. Vivid images filled the media, boat rescues in flooded suburbs, social media feeds overflowing with pleas for help. photos of soaked families awaiting rescue, levees barely holding back brown, roiling waters. For days, the distinction between city and floodplain was erased. In Southern California, the scars of recent wildfires heightened the crisis. Rain was unable to soak into hillsides left hydrophobic by fire. Debris flows, thick, fast-moving mud and rock, rushed down canyons, overwhelming cars, and, at times, tearing away houses. Thousands faced mandatory evacuations, some for the second time in a year. California's highways, the arteries for commerce and escape, were paralyzed. Interstate 5 and Highway 101 closed in several stretches due to flooding and mudslides. Interstate 80 through the Sierra was blocked with deep snow and blizzard conditions, leaving vehicles stranded. At the height of the crisis, unrelenting storms continued to exact their toll. Hundreds of thousands lost power, sometimes for days. Roads and bridges vanished. Entire towns were isolated behind breached levees and impassable routes. The death toll mounted. At least 3 fatalities were confirmed in Southern California, alongside additional deaths elsewhere as trees fell and floodwaters rose. Over 200,000 people had fled their homes, losses climbing into the billions of dollars. None of this was pure chance. The storms pounding California were tied to deep-rooted shifts in atmospheric patterns, changes so marked that meteorologists watched with mounting concern. A persistent pattern in the jet stream had set up a direct fire hose from the tropics toward the Pacific coast. Rather than wandering, the atmospheric rivers repeatedly hit a narrow swath of California, landing in familiar flood zones over and over. Dr. Sarah Chen, an atmospheric scientist at UC Berkeley, observed satellite data documenting what prior generations had rarely seen. Atmospheric rivers are not just stronger, they're lasting longer and striking the same regions again and again, she warned. California's saturated soils, normally damp a few feet down in winter, were now sodden to 6 feet deep. Groundwater stores, reservoirs, and river basins had little capacity to absorb further rainfall. Each additional storm nudged the system closer to catastrophe. Sometimes described as storms you can see from space, atmospheric rivers have always delivered a crucial share of California's water. But in this new regime, Dr. Chen explained, they posed the state's gravest threat. The latest storm sequence seemed to bridge categories, blurring lines between routine and exceptional, combining broad, persistent flows with sudden, intense bursts. And the pattern refused to budge. Weather models, usually cautious, now predicted 2 or more fresh atmospheric rivers would make landfall in the coming weeks, each feeding on a warmer, wetter atmosphere. In higher elevations, rain fell where snow was once assured, accelerating runoff and amplifying flood risk. As atmospheric rivers pummeled California, levees became the chain's most visible weak links. These embankments, stretching roughly 24,000 miles, protect over 23 million residents and trillions in assets. But many segments are decades old, inconsistently upgraded, and under-monitored. The American Society of Civil Engineers had already rated California's levees at a troubling D+ before the crisis, a warning that seemed generous under the pounding of atmospheric rivers. When levees break, catastrophe is sudden. Water surges in, neighborhoods fill like buckets. Recovery takes weeks, pumps running continuously against the tide. For small towns and agricultural communities, each failure posed existential questions. Could families return? Would fields ever yield crops again? Could the levees, built and patched across generations, be counted on going forward? Repair proved a race against time. River after river pressed at levees already weakened, and waterlogged soils offered little resistance. Officials admitted that infrastructure investments had lagged far behind threats. Deferred maintenance now paid for in ruined neighborhoods and upended lives. Ultimately, the levee system, designed for an earlier climate, proved unable to cope with the atmospheric river's relentless siege. It was not just a failure of physical structures, but of the assumptions underpinning California's bargain with its environment. February brought still greater intensity. A new storm, ranked at the top of the atmospheric river scale, hit Southern California with rainfall and winds not seen in generations. Los Angeles experienced its wettest day since the 19th century, as rain fell in inches per hour, and 70-mile-per-hour gusts brought down power lines and trees across the region. Downtown Los Angeles flooded just as drains filled, then overflowed. Communities like Long Beach and Pasadena reported 3 to 4 inches in a day. The San Gabriel Mountains upwards of 6. Evacuation orders swept through Los Angeles and Ventura counties, sending tens of thousands to overflowing shelters. Fresh scars from January's wildfires became dangerous flashpoints as debris flows several feet deep ripped through hillside neighborhoods, burying homes, sweeping vehicles down ravines, and cutting off entire areas. Elsewhere, the Bay Area faced not only storm surge, but rare winter king tides. San Francisco's Embarcadero vanished beneath a mix of floodwater and high tides, submerging trolleys, BART tunnels, and the famous ferry building concourse. Fisherman's Wharf, usually bustling, stood empty under feet of water. To the east, the Sierra Nevada was slammed by over 4 feet of snow in 2 days. Too much, too quickly. Towns like Truckee and South Lake Tahoe declared states of emergency as roofs collapsed under the snow's sudden weight, and avalanches became an ever-present risk. The flood's tally was staggering. Damage estimates doubled, topping $12 billion. Insured losses soared. The agriculture sector, already battered by flooding, sustained billions in further losses as fields remained underwater and equipment wrecked. The toll in human terms was yet more sobering. The fabric of daily life upended, certainty swept away by rising waters.
The torrential pattern did not relent. Atmospheric river after atmospheric river continued to braid moisture across the Pacific, their impacts amplified by a state too sodden to absorb more. Scientists, pressed by the urgency of unfolding disaster, reported that the latest storms did not resemble classic, singular atmospheric rivers, but rather a string of intermediate events, each one feeding off the last, each one delivering more precipitation as ground and levees were overwhelmed. "We're witnessing the need to update our scale," Dr. Chen explained. "The strength of each atmospheric river is no longer just a matter of how much water is in the air, but how primed the ground is below to let that water loose." She advocated urgent incorporation of soil moisture and antecedent conditions into the forecasting system, measures that, in testing, promised communities critical hours of warning before flooding could be confirmed. But enhanced warnings could only do so much. They couldn't rebuild levees overnight, or drain reservoirs, or move rivers back into pre-flood courses. Warnings merely bought time for evacuation, and for triage by overwhelmed emergency systems. Underlying it all, the scientific verdict was becoming clear. Climate change had altered the rules. Global research found that atmospheric rivers were shifting poleward, their watery plumes reaching California more frequently and more powerfully. For every degree the planet warms, the air's capacity to hold vapor increases by about 7%. The result? More moisture, more deluge when wind patterns funnel these rivers onto land. With each storm, the damage compounded. The soil's memory of recent floods meant even moderate rainfall could cascade into major floods. The resignation grew that these events were no longer freakish, but likely to recur. The statistics of the season painted a new reality. Over the winter, California received roughly 150% of its average precipitation, a bounty in theory, but one delivered as frequent disasters, not steady relief. Reservoirs, left low after years of drought, now overflowed. But the benefit was fleeting as silt-clogged channels and overwhelmed levees let precious water wash away. Up in the Sierra Nevada, the snowpack reached 20% above normal, yet much of the precipitation that could have been stored as snow instead fell as rain, even in high elevations. This accelerated downstream floods and failed to lock water safely away for spring. Communities bore deeper wounds. Insurance climbed out of reach for many living on floodplains. Families who had evacuated multiple times now considered relocating for good, a trend mirrored by a sudden increase in home sales in at-risk areas. For many, trauma outlasted the rain. Life continued in temporary shelters, schools co-opted as evacuation centers, children rocked by the instability of displacement and the constant vigilance of weather alerts. Parents offered drained reassurances, explaining missing pets, uncertain housing, daily disruptions.
In a state long defined by drought and wildfire, a new migration began, not seeking water, but fleeing it. Still, the cycle kept spinning. As the final evacuees returned from shelters in February, new atmospheric rivers were forecast to make landfall before March was out, promising more threat before any true recovery could begin.
California's future, clearly, was a story still being written in water. No one can say just how many atmospheric rivers will sweep over the Pacific before this year concludes, nor how many more repairs levees and cities can endure. One fact is constant: the line dividing storms from catastrophe is now drawn not just by fate, but by saturated earth and the unfinished work of adaptation. Preparation is no longer enough when every inch of ground is sodden and every sky threatens more rain. The rivers moving overhead now dwarf everything built below. They carry not just water, but a power that carves valleys, washes away towns, and forces California to reconsider old understandings. The world is watching as California strives to endure. When the floodwaters finally recede, what will remain, what will be rebuilt, remains to be seen. The lessons are already studied, the stories of survival and loss echoing through displaced families and battered towns. The floods of 2026 will not be remembered as simply a tragic season, but as a turning point, the new normal for a state and a world where atmospheric rivers are both lifeline and threat. And as another column of moisture forms over the Pacific, warnings rise again. A generation holds its breath, and California prepares to endure the next flood, to define anew what endurance in the face of water truly means.